Hello, welcome to my chemistry review number 7. Today our topic is solubility and polarization of a bond. To explain all these concepts, I prefer to use a hydrogen atom and a hydrogen molecule. If I can remind you that a hydrogen atom is made up of one proton inside the nucleus, and I use this symbol for the proton because you can remember always that a proton has a positive charge, and I had this symbol for the electron. It looks like a minus sign. So the electron is negatively charged and it is moving around the nucleus. Not only that, a proton has a relative charge of +1, and this electron has a relative charge of -1. Therefore, +1 -1 is 0. Therefore, our hydrogen atom is neutral. It has a 0 charge. And the atoms are unstable. These kind of atoms are unstable. Therefore, two hydrogen atoms will join together, share their electrons in the middle to make a hydrogen molecule like this. So I have colored this one black and this one red. This black colored electron belongs to this atom. Red colored electron belongs to this atom. And remember, even though I haven't drawn, this atom has a positively charged proton in the nucleus, and same is true with this one. We can draw these molecules like these two. This is my one of the H atoms, so I am drawing their symbols, and this is my other H atom, and their charges are 0 because proton and the electron cancels out. Therefore, this atom has a charge of 0. This atom has a charge of 0. Usually, we don't write this 0 charge, but I want to compare something. Now, I am going to show you using this hydrogen molecule. I use the hydrogen molecule because it's the simplest molecule we have. Now this molecule, if I break this molecule from the middle like this, what is the end result? This atom will take this electron, this atom will take this electron. So they will end up with two atoms with 0 charge. +1 -1 is equal to 0. So we end up with two atoms. What is the meaning of this plus here? It means and. This atom and this atom. On the other hand, if we happen to break the molecule from here, what will happen? From the side. Then this atom is stealing other atoms' electron. So it is getting one more electron. So the total charge will be +1 -1 -1. So it will have a -1 charge. And the other atom will have only one proton that it already had in the nucleus. So it will have a +1 charge. Due to some reason, I have colored it red and the previous one in blue. Now I am going to show you a story in between these 0 and -1, 0 and +1. Is there anything in between these two? So let me first show you a number line. This is my number line, 0 in the middle, +1 here, -1 here. So think about a small positive number, like I pick up 0.01. I call it plus delta. This symbol delta is almost like the number 8, but this part is empty. So delta represents always a small number. And -0.01, I call it minus delta. You will see the reason in a while. What I'm going to show is, instead of breaking the bonds, because of the high electronegativity of this atom compared to this pair of electrons will be pushed little bit towards one of the atoms in the bond. Then your situation will be, you are not breaking the bond, but this atom will have a small negative charge. Small negative charge. Not exactly -1 like before. So we say that it will have a small negative charge and this will have a small positive charge because of this reason of pushing the electron pair to one side. So we draw it like this. This atom became minus delta charge. This atom became plus delta charge. And we say that the bond is polarized now. The concept is called polarization. But remember, it doesn't happen in hydrogen molecule because there is no reason for one atom to grab the electron density towards it because both atoms are the same. But I use these molecules to explain the three types of concepts. Now, I said that that the third story happens because of the electronegativity difference. We discussed about the electronegativity in lesson number 6. In red color you can see the electronegativities in my rough periodic table. And now let's work out randomly electronegativity difference for sodium and chlorine. Sodium 0.9, chlorine 3.0. So I use the capital delta sign to show the electronegativity difference, delta En, electronegativity difference. So big one minus small one, 2.1. Keep that in mind. And this diagram shows you 0, 0.5, 1.7. If the electronegativity difference is more than roughly 1.7, it's going to become an ionic compound. That means one atom is much more electronegative than the other one. So it completely takes the other person's electron to himself. So it became Cl minus and Na plus. The one that I showed you previously in this one. One became plus, one became minus. And now let's look at the electronegativity difference in HCl. It's going to be 0.9. So in between 0.5 and 1.7, we call that a bond polar covalent. That means it is sharing electrons, but because of the high electronegativity of this one compared to this one, this atom will have a small negative charge, this atom will have a small positive charge. If the electronegativity difference is between 0 and 0.5, we say that it's a purely covalent bond. So the electron pair is sitting in the middle. If we work out for OH bond, it is going to be 1.4. Again, it's a polar covalent bond. Oxygen is more electronegative, so it has a small negative charge, small positive charge. Therefore, when we draw the water molecule, we talked about it earlier, we draw their small charges like this. Oxygen minus delta, H plus delta, other H also plus delta. So the bonds are polarized like this. So for example, this H atom has a small positive charge. Now we are going to think about our solubility. some substances are soluble in water, some are not. Remember, we talked about the sodium chloride in earlier lessons. This is my solid sodium chloride. Sodium ions in purple color and chloride ions in green color. They are nicely packed like this. One atom cannot move from one place to another. But if you dissolve the sodium chloride or table salt in water, this is what will happen. This lattice will break and each sodium ion will be surrounded by several water molecules like this. See, the water molecules are showing their negative sides to the positively charged sodium ion. So they make a small electrostatic attraction between these two. So this process is called solvation. And another set of water molecules will surround the chloride ion. But in this case, positive sides of the water molecule will be facing the chloride ion, negatively charged chloride ion. I have drawn only two molecules, but there will be several molecules sitting around the chloride ion. So when you dissolve your sodium chloride in water, the solid sodium chloride lattice will be broken and it will be dissolved in water. And after this solvation, the sodium ions and the chloride ions can freely move around in water. They can nicely swim around in the water. And when you dissolve something in water, we call, in this case, a piece of sodium chloride, we call solute. And we call the liquid solvent. And the resulting mixture we call sodium chloride solution. And sometimes it's called NaCl with a subscript aqueous, AQ. So aqueous means dissolved in water. Why does this solvation take place? We need energy to break this lattice, and then when this solvation takes place, some energy will be released. So in a future lesson, we will talk about the energy requirements and energy stories. But I hope that you understood the solvation process or dissolving process. And if you have a difficulty, watch this again. And in my next lesson, I hope to talk about types of reactions, starting with single displacement reactions. Thank you for watching.